In the xy plane, region R consists of all the points xy such that 2x plus 3y is less than or equal to 6. Is the point Rx in region R? So in other words, we want to find pairs of real numbers that satisfy the blue inequality. So statement number 1 tells us that 3y plus 2s equals 6. So it's going to be hard to try and figure out with algebra how this equation relates to the blue inequality. So I'm just going to pick some numbers and see what happens. And of course, if we can pick numbers that go either way, it tells us the statement is insufficient. So I notice, for example, that if r equals 2 and s equals 0, that satisfies this equation. We'll plug that into the blue inequality. We get 4 plus 0 is indeed less than 6. So 2, 0 does work. I can also plug in 0, 3. So this also satisfies the equation. If I plug this into the blue inequality, what I get is 0 plus 9. That equals 9, and of course that is not less than 6, so that doesn't work. So I can pick one pair that does fit the inequality, one pair that doesn't fit the inequality. So that means that this equation in statement number 1 by itself is insufficient. Now leave that aside. Move on to statement number 2. Statement number 2 tells us that r is less than or equal to 3, s is less than or equal to 2. Again, same thing. I'll pick some points. Well, according to this, I could actually pick r equals 3, s equals 2. I could pick that maximum point. When I plug that into the blue inequality, what I get is 6 plus 6, which is 12. That doesn't work. But of course, I could also pick 0, 0, and when I plug that into the inequality, I get 0 plus 0 is 0, which is less than 6, so that does work. So again, I can pick points that work and points that don't work, so it means that this statement by itself is still insufficient. So now the grand finale, now we have to combine the two statements. So now we need things that satisfy the equation 3r plus 2s equals 6 and satisfy the conditions r's less than 3 and s is less than 2. So again, let's see. I can certainly plug in the point 2, 0 again. 2, 0, and as we saw, that works. So that satisfies all the conditions, and that's an example of a point that works. But suppose, let's see, s can be up to 2, so let's make s a maximum. Let's make s 2, and then in order to equal 6, 2 times 2 is 4, so 3r would have to equal 2, so that means r would have to be 2/3. And so the point 2/3, 2 satisfies this equation, satisfies both of these inequalities. R is less than 3 and s is less than 2. Now let's plug this into the blue inequality, and what I get is 2 times x, so that's 4/3, plus 3 times 2, which is 6. And of course, that's greater than 6. We don't even have to figure out what it is. We know that it's greater than 6, so it doesn't satisfy the inequality. So even with both statements combined, we can pick some points that satisfy the inequality and some points that don't satisfy the inequality. And so that means even with both statements combined, we still have insufficient information to answer the question whether RS is in region R. Now, if all this stuff is a lot to keep in mind, I'd recommend Magoosh.com. We have several videos that help with understanding inequalities. The answer to this is E.